Know about scapulothoracic and GH function in scapulohumeral rhythm. So first let's see. So the 2:1 ratio. You know. So what does this 2:1 ratio means? The GH joint which is contribute for this 2 and 1 is contributed by the scapulothoracic. Okay. So for example, if you see a 90 degree of arm elevation. So 90 degree of arm elevation. So here the 60 degree is done by our GH joint and the another 30 degree which is done by the scapulothoracic motion. So but research says that it is a oversimplification of the elevation of arm. So which is giving you an idea about it. So then we move on. So let's move on to the very important thing we need to know. So while during the arm elevation, so which just means both the scaption and the arm flexion and also the arm abduction. So in the three aspects, so what our scapula contributes that is posterior tilting, which will occur. So I will write it down. So while the scapula, let's say this is a scapula. So just for a simplification, I just draw here. So it is going for a posterior tilting. So if it goes for a posterior tilting, which means this aspect you see here, so this will go for posteriorly tilted, so the upward part. So if it comes for posterior tilting, the downward part, which is the inferior angle of the scapula, which is moved anteriorly. So this one will move anteriorly. So why it helps means, if it moves anteriorly, so here there is a thorax. So there is a thorax. So if it moves anteriorly, it will stay in contact with the thorax. So it will help for you when it moves upward rotation. And this is a scapula which is moves an upward rotation. So if it moves an upward rotation, still it needs to be contact with the thorax. So here it is contact with the thorax. So for that we know, so this posterior tilting which leads to anterior tilting, so the anteriorly placement of inferior angle of the scapula. So inferior angle of the scapula which is placed anteriorly moving. This is the first thing we need to have. So the second benefit we can have because of the posterior tilting of the scapula is, this is a scapula. It also has the acromion and all those steps is here, right? So if it's go for a posterior tilting, so this part, the upward part will go for a posterior tilting. Also the acromion here, right? So the acromion also will come back and also anteriorly release the anterior acromion up and the back. So what's the benefits it coming back means? So it will minimize the reduction in the subacromial space. So while we go for a humeral elevation, so it minimizes the space in subacromial space. These two things will happen because of the posterior tilting of the scapula. So now we'll go for next one. So next is externally rotating on the thorax. So scapula is externally rotating on the thorax. So now we'll go forward. So this external rotation is happening during the end range of elevation. So while we go for end ranges, the external rotation will take place. Also here the internal rotation also occurs in the scapula during the initial stages, which is early in the ROM for flexion. So for flexion only the internal rotation is happening. So the excessive internal rotation of the scapula does not need to happen. So which is prevented by the medial border. So here I will draw the medial border. So this is the medial border, right? So here, just see here, this is the medial border. So this medial border of the scapula, which is contact in the thorax. So it will prevent the excessive internal rotation of the scapula. So but in during the arm flexion, so here there is a glenoid fossa. So here there is a glenoid fossa is happening. So this is medial and this is the lateral one. So while during the flexion, so here there is a, you see this is a humerus. So while go for a flexion, so this will go for, our scapula will go for protraction, or also a slight internal rotation needs to be happen. So that's why the glenoid fossa will get oriented. So for that reason, the internal rotation is needed for the scapula.